We're going to start today talking about how you can calculate doses. So, this is, of course, something that you're going to have to do an awful lot if you want to go into veterinary medicine. And obviously, it's not just about vets. This kind of applies to human medicine and things like that as well. But for most of you, this is going to be about vet stuff. So we'll look at particularly focuses on that. Now, sometimes when you are calculating doses, you will get a nice formula, which will tell you something like, give this number of pills per this amount of body weight or something. And in that case, you might just have a simple formula that you can use. But sometimes it's not quite that easy. And one of the ways that you can make sure that you're working things out correctly, even if you don't just have a formula given to you, is you can think about the units. And think about making the units work. Okay, now this is what some people call dimensional analysis. In general, this just means that you're checking through your units and you're making sure that whatever you're doing, all the correct units cancel in the way that you want them to, and you end up with the right thing in the end. So I want to just go over a few examples of how this kind of thing, using these units, works in some relatively simple examples, and then we're going to build up to doing more and more complicated examples as we go. So let's first of all start with the following problem. Let's suppose that a certain medicine is given at a rate of 2 ounces per 50 pounds of body weight. And we want to know how much do we give a 75-pound dog. Okay, so we have a 75-pound dog. Now, here's what we know. We need to give 2 ounces per pound of body weight. And the thing that we know about this is we want all of the units to work out. So what we're going to do is we're going to start with this 75 pounds of body weight. Whoops, that's not how you put pounds. So we have 75 pounds of body weight. And what we want to end up with is ounces of medicine. That's what we ultimately want. So you can think of this as 2 ounces of medicine. That looks like a 20. It almost looks like I wrote O twice. I'm sorry about that. It's supposed to be 2 ounces per 50 pounds. So we want to end with ounces of medicine. So we have 75 pounds of body weight. We want to multiply that by the ounces per pound of body weight to cancel out the pounds of weight. And so we're going to multiply by 2 ounces of medicine per 50 pound of body weight. So the pounds of body weight cancel out here, and we are left with 75 times 2 divided by 50. Well, this comes out to be 3, and the units here are the ounces of medicine. So we get 3 ounces of medicine. This is a fairly straightforward example because all you have to do is to multiply, by this rate that you give the medicine, the dosage rate, in order to get it. Okay, so it's a fairly simple formula. What I want to illustrate with this is how I was keeping track of the units and what they stand for and making sure that they cancel out. So I need my pounds of body weight to cancel out, and I need to be left with ounces of medicine. Now, the reason that this is important and the reason that you want to kind of think about this method when you're calculating doses is because you're not always going to have some nice formula that you can just say, oh yeah, just take the weight and multiply it by this or that. Okay, sometimes you're going to have to work things out a little bit differently. It might be more complicated than that. It may not even involve weight. So here's an example of a dose that maybe doesn't include body weight at all. Now, a lot of them, I will tell you, they probably do include body weight as part of the dose rate, but something per body weight, but not always. There are cases where you're going to do something where it's not some amount per body weight. It's going to be something else. So let's suppose that horses get, let's say, 3 cc's per 5 inches of height at the withers. And we'll say it's 3 cc's of some medicine. I don't know what medicine it is. But so what this is saying is that instead of measuring the weight of the horse, you measure how tall is the horse at the withers. I think that's the correct word for shoulder here, although horse people, feel free to let me know if I've screwed up the terminology somehow. You measure the height at the shoulder, basically, and then you use that. So let's suppose that we measure that the horse has a height of 75 inches at the withers, and we want to know how much do we give it. Well, in this case, we need to make sure that our units are going to work out. So we need to end with cc's as our unit. That should be our final unit. And we want to do this per height at the withers in inches. So we're going to take our 75 inches, and it's really inches at the withers, although I'm not going to keep writing out all of those units. Just kind of keep track of that in your head. 75 inches at the withers times, let's see, we said 3 cc's per 5 inches. The inches will cancel here and leave me with the cc unit, which is what I want. So this becomes 75 times 3 divided by 5. And that is going to actually come out to be, let's see, 75 divided by 5 is going to be 15. Yes, 15. I don't know why that took me so long to do in my head, but it comes out to be 15. 15 times 3 is 45, so we get 45 cc's. By the way, a cc is a cubic centimeter, and it's one of the ways that you often measure the amount of stuff that you're injecting into something. So it's a very convenient way to measure some liquid that you're going to inject, because you often, on your syringe, it's easy to measure the volume in the syringe. You can't measure the weight of a medication that you're putting into a syringe necessarily, though. Or you could, but you'd have to put the syringe on a scale or do something like that, right? So you wouldn't be able to just directly say, hey, I'm going to give, this number of ounces of this medicine, because then you'd have to take your syringe, you'd have to weigh the syringe, fill it up, weigh it with the liquid, subtract the difference, figure out what the weight of the liquid inside the syringe is. It'd be a pain. So we measure things in volumes instead in this case. Now, this is going to give us an illustration here of why it is so important to think about units here and not just memorize formulas, okay? Let's take this same problem, but let's change it around a little bit. So let's suppose that instead of giving you the height of the horse in inches, let's say that a horse is 5.5 feet at the withers. And we want to know how much do we give it. Here's where you could screw up if you just memorize formulas and start plugging in numbers. If I just took 5.5, I don't know why there's a little mark there, I just forgot to erase it. That wasn't supposed to be indicating anything. If I just took 5.5 and multiplied it by 3 over 5, this would be wrong. The reason it wouldn't work is because this height is in feet and this is in per 5 inches. So I need to get this not in feet but in inches first. So here's what I can do. I can take, to make it right, I can say, okay, we have the 5.5 inches. Let's multiply that by 1 foot per 12 inches. And now, when I do that, the inches... I wrote inches instead of feet. Yeah, let's back up a moment and actually get the units right this time, shall we? 5.5 feet times 12 inches per foot. Now, the feet cancel. Okay, so now you might think, oh, that was just a silly mistake on my part. But it actually illustrates very nicely what I was just talking about with keeping track of the units. I was looking at that and I was thinking, wait a second, these units aren't going to work. And it showed me that I'd accidentally written the wrong factor here. I'd written 1 over 12 when I really wanted to multiply by 12, not by 1 over 12. If I hadn't had the units there, if I hadn't noticed that something screwy was going on with the units, I might have never noticed that, and that would be disastrous for my patient. So, keeping track of the units is really going to help you. Now that I have this in inches, I can multiply it by 3 cc's per 5 inches. When I do that, the inches will cancel and I'm left with something that is in cc's. And that is what I want to have. I want to end up with cc's. Now, let's see if we can multiply this whole thing out. So we're going to get 5.5 times 12 times 3, all divided by 5. So this is going to become 5.5 times 36 divided by 5 cc's. So 5 times 36 would be 180, and another 0.5 times 36, that would add 18. So this becomes 198 over 5 cc's, and that is going to come out to be, let's see, if I divided this by 10, I would get 19.8. Double that, and I'm going to get 38.6 cc's. Okay. I'm sorry, 39.6. I did that wrong in my head. I was like, wait, that doesn't quite make sense. 39.6. You double this, 19 doubles to 38, and then the 0.8 doubles to 1.6. So 39.6 cc's. So you can see that I was able to avoid making a mistake here, which I actually almost made because I was trying to talk and write at the same time, and I started writing the wrong conversion thing here. But by keeping track of the units, I was able to make sure that everything was working out for me. Let's take a look at one more example of this kind of thing. Let's say that I have a problem here where rabbits receive, let's say, 1.5 cc's per every 300 grams body weight. And we want to know how much do we give a 1.5 kilogram rabbit. Okay, once again, you can't just start throwing numbers in from this without thinking about it a bit, okay? You have to think about the units that are involved. So if I have something in kilograms, but this is in cubic centimeters per grams, I need to convert this into grams first. So I have 1.5 kilograms. I need to multiply that by 1,000 grams per kilogram before I do anything else. Now I can multiply by 1.5 cc's per 300 grams. When I do that, that will cancel out the grams and it will leave me with cc's. So that leaves me with the units that I'm actually going to be measuring the medicine in. And that's the actual, here's the thing I'm going to give it, okay? So I measure what we're giving it in the cubic centimeters that we're going to inject. And so I want to end with those units. So this ends with some units in cc's, and so this is going to become 1.5 times 1,000 times another 1.5, all divided by 300. So canceling things out a bit here, we're going to have 15 times 1.5 divided by 3. Because I canceled out the 300 cancels to make this 1.5 times 10 times 1.5 divided by 3. That gives me 15 times 1.5 divided by 3. This becomes 5 times 1.5, and that's going to become 7.5 cc's. So the answer is that we want to give this rabbit 7.5 cc's. So what I would like you guys to do is take a look in your books at the chapter on calculating doses and start practicing those practice set problems, okay? But when you're doing this practice, make sure that you keep in mind, okay, we've got to always think about the units that are involved. Don't just try to think of what's the formula. Try to ask yourself, how do I convert these units? How do I make sure that the units work for me? And when you are doing this, the thing that you want to remember is that you want to end with units of what you actually give to the patient. Sometimes that will be cc's. Sometimes it might be measured in, I don't know, grams. Sometimes it might be measured in a number of tablets, okay? We'll talk more about that on our next lecture. How do you deal with things like that sort of thing? And you'll learn more about that in your actual vet courses. Because, of course, for all of these medications, there's going to be some specific instructions for, you know, how do you make sure that you calculate this stuff. I'm just giving you kind of the general approach that you can always use, but do always make sure to follow whatever directions come along with whatever medicine you're dealing with. But you want to end with the units of whatever you're going to give to the patient. If that's cc's, you do it in cc's. If it's going to be in tablets, then you want to end up with tablets. And as you work through the problem, you start with some measurement about the patient. You need to multiply by stuff that's going to get rid of the measurements about the patient. Those units need to cancel, and you need to end up with units of what you give to the patient themselves. So start practicing those problems. Let me know if you have questions, and we will do more examples of this later this week.